Hello everyone. This video is a continuation of the previous video. Okay, so coming to fractional distillation now. Um, First of all, what is the meaning of the word fraction? Fraction meaning is a part. All right. Now coming to the first point, fractional distillation, okay, is done in a fractionating tower. So this is your fractionating tower, right? Uh, Now fraction meaning part. So in a fractionating tower, you have all these different parts. Okay, it is divided into different parts. Now, um, petroleum is first, coming to the second point, petroleum is first heated to 400 degrees Celsius in a furnace to convert it into vapor. So the first thing that is done in fractional distillation is convert the crude oil into vapor by heating it in a furnace. This is your furnace. Okay, now this crude oil is heated to a temperature of 400 degrees Celsius. When that is done, this crude oil will change into vapor. Okay, now once vapor no once the crude oil changes into vapor, it is then released into the fractionating tower. Right, now this is your vapor. Okay, so this vapor then goes up, and at the same time it also cools down. Right, you can see the as you go up, the temperature is decreasing, right, from 400 to from 400 to 370, 370 to 300, 300 to 200, 200 to 150. Right, so as the vapor goes up, it starts to cool down. Okay, now when it cools down, it condenses, okay, at different heights. Now here's the thing, see, you are all aware of the fact that in crude oil there are so many components. Okay, like you have the your petrol, diesel, then kerosene, then you have lubricants, right? You have lubricants, then you have paraffin wax, then you have tubuman, no, butaman, right? All of those things, um, you have it in your crude oil, and these components, they are all, um, I mean, like they have different boiling points. Okay, so depending on the boiling point of the different components, they will condense at different levels, that is in different compartments, the parts in the fractionating tower. Right, now the higher the boiling point, lower will be the condensation level in the fractionating tower. Right, for example, here let's see in the on the screen, you have, no, in the diagram you have the lubricants here, right? So the lubricant is condensing at a level in a compartment lower than that of diesel, right? So that means the lubricants have a higher melting point. Okay, the higher melting point will condense at a lower level, right? This is it. Okay, so same likewise, since diesel is condensing at a lower level than kerosene, that means it has a higher boiling point than that of kerosene. So it is condensing in this level. Then same with kerosene, petrol and kerosene. Kerosene has higher melting point. No, sorry, boiling point. So it is condensing at a level lower than that of petrol. Okay, so The higher the boiling point, lower will be the condensation level in the fractionating tower. And this condensed components, okay, which are now they are separated. So they are collected um, and used for their respective purposes. Now, some components do not condense and escape from the fractionating tower as petroleum gas. Okay, no, sorry, what did I just say? Some components do not condense and escapes from the fractionating tower as petroleum gas. Now, all of this vapor that is sent up from the bottom, okay, all of the vapor that is sent up from the bottom will not condense. Some escapes as petroleum gas, okay, in the form of butane and propane. Okay, now coming to the next topic, natural gas. Natural gas is colorless, odorless, and tasteless, right? Now, odorless meaning it does not have any smell, okay? And it is also a fossil fuel that exists naturally. It is mainly made of methane and other hydrocarbons. Now, I have already given you an example in the previous video, that was methane. Now, other examples of hydrocarbons will be propane, okay, propane and butane, okay. So these are other examples of hydrocarbons. Then it is the fourth point, it is found under the crust of the earth, either alone or with petroleum deposits. That means um, the natural gas will exist all by itself, alone, okay, or with crude oil in oil reservoirs, right? And it is extracted the same way as crude oil. Now, crude oil, we know from, we already did it from the previous previous video, that crude oil is extracted by boring deep down the earth, right? So natural gas is also extracted in the same way, okay? Then they are also found in marshy areas and landfills. Now, marshy areas are nothing but wetlands, okay? And landfills are um, areas where you dump earth, okay? Now see, here, when earth is dumped, okay, some vegetations are buried under, okay. So these vegetations, they start to decompose in the absence of air, and when they decompose in the absence of air, methane gas is produced, okay. And we know that methane is the main component of natural gas. So in landfills also natural gas is found. Then um, characteristics of natural gas. Natural gas has high calorific value. High calorific value meaning when it burns, okay, it gives you a large amount of energy, and then it catches it catches fire very easily. And it is considered more environment friendly due to low emission of pollutants. Okay, that means there is no residue after burning. For example, see, take the case of petrol, diesel. They are used in cars and buses. Now, um, this produces a lot of smoke. Okay, but in case of natural gas, no smoke is produced, so it does not pollute the environment. So it is considered more environment friendly. Then it is lighter than air and dissipates easily. Dissipates is nothing but disperse, okay, which makes it safer to use. How does this make it safer to use? See, for example, let's say there's a gas leak, okay. So because natural gas disperses easily, the concentration of the gas, okay, um, lowers much faster, okay. So this uh, decreases the chances of catching fire easily, right? So it becomes much safer to use. Then it is easy to store and transport. It can be compressed and filled into cylinders. This basically means that a large amount of gas, okay, a large amount of gas can be filled into a very small container. For example, let's say your LPG gas that is being used in the kitchen. Okay, in that LPG gas, LPG cylinder, there is a very large amount of gas. How is it um, done? That is by compressing the gas, right? Then it is cheaper than other types of fuels. Means it's less expensive, right? Very simple as that. Then coming to the next topic, alternative fuels. Okay, natural gas from biomass. Now, biomass refers to organic matter that contains stored energy from photosynthesis. This energy is transferred from to animals through the food chain. Now, see, photosynthesis is nothing but plants making their own food in the presence of sunlight. Now, the ultimate source of energy is from the sun, right? From the um, okay, from the sun, light energy is used, and then plants through photosynthesis they make um, glucose. Okay, now glucose is the form of energy, right? Now um, that now when plants are eaten by some other animals, the energy is being transferred. Okay, see here the energy is transferred to animals through the food chain. The food chain is nothing but like from grass. Grass will be eaten by cow or deer. Okay, then deer will be eaten by tiger. Okay, so this is an example of food chain, right? One organism eats the other. Now here, so what is happening is there is transfer of energy taking place, okay, from one level to another. So that is your food chain. Okay, then biomass mainly consists of plant parts like fallen leaves, grass, fallen trees, vegetables, and fruit peels. Okay, biomass can be converted to natural gas, that is methane, and is used as more efficient, cleaner source of energy. Uh, See, here's a question. If biomass is mainly of plant parts, then like fallen leaves, then grass, trees, vegetables, fruit peels, how can it be converted to natural gas? Okay, see, the main component of natural gas is methane, right? Now, when uh, this organic matter, that is fallen leaves, grass, okay, vegetables, then all these fruit peels, all this organic matter, when they are made to decompose in the absence of air, right? Methane gas is produced. Okay, and methane gas is nothing but the main component of natural gas. So that way, artificially, biomass can be converted to natural gas. Okay. Um, Now, biomass can be converted to natural gas, methane, and is used as a more efficient and cleaner source of energy. Um, then, the next point is biomass has become the most renewable source of energy in the last 2 decades. That means in the last 20 years. Okay, most renewable means it can be replenished again and again. Okay, even though you use up, you can still replenish that. You can still replace that energy. Okay, um, by converting it into uh, natural gas, right? So that's it for our videos. I will see you in the next video.